Hello Math 109 students. We're looking at 1.5 in this video. Section 1.5 is kind of a hodgepodge of different kinds of equations and how to solve them. They are radical equations, equations that are quadratic in form, so not necessarily quadratic, but quadratic in form, absolute value equations, and higher order factoring. All right, here's our first example. Find the real solutions of this equation, and it is a radical equation. You could do the calculator. As I've been showing you in earlier videos, you could put the left side of the equation into y1, and then if you want to find where it equals 0, you find where it crosses the x-axis. You find these zeros of the function. But to solve this by hand, I'll show you. All right, we're trying to get x by itself, so we're trying to get rid of anything on the left side that's with the x. So the first thing I would do is I would get rid of that minus 2 by adding 2 to both sides. And then the next thing I need to get rid of is this cube root radical right here. Well, I got to get rid of it by using whatever is the opposite of that, and that would be a cubed exponent. And as long as I do the same thing to both sides, that's a good thing. That's fine. So that cancels out the cube root, and so I've got 2x minus 4 equals 2 cubed over on the right side is 8. Then just add 4 and divide by 2, and x equals 6 in this example. Now, a little bit of bad news about this is sometimes when you raise the powers, when part of your step involves raising something to a power, it can increase the number of solutions. In fact, it can give you solutions that are not true solutions to the original problem. So we actually have to go back and put our answers that we get back into the original problem and see if they come out to be true. 2 times 6 minus 4 minus 2 equals 0. So this is going to be, that's 12 minus 4. That's going to be 8. So the cube root of 8 minus 2. And the cube root of 8 is 2. And 2 minus 2 equals 0. 0 equals 0. That checks out. So this is a good solution. So x equals 6 is a good solution. All right. Moving on to another example. Why is it doing that? I don't want you to do that. There we go. Okay, another radical equation. What I will do here is I will raise both sides. What I'm trying to do here is I'm trying to get rid of that radical, and that is a square root. There's an invisible 2. There is an invisible 2 serving as the index of that radical. So to get rid of a square root, you use a squared exponent, and I'll do that on both sides, and that squared exponent gets rid of that square root. So it gives me x minus 1 on the left, and on the right I have to FOIL out x minus 7 with itself. I got to do x minus 7 times x minus 7. And when I do, I get x squared minus 7x plus 49. So that's x squared minus 14x plus 49. Now I'm going to move everything to the same side. I'm going to subtract the x and add the 1. And that's going to give me 0 equals x squared minus 15x plus 50. And from here, I have just a normal quadratic equation that you've already seen how to solve this in multiple ways. You can do the quadratic formula, but I prefer to factor if possible. And I think it's possible to factor this. I think I say that's x minus 10 and x minus 5. So x equals 10 and 5 whenever I set those equal to 0 and solve them. 10 and 5 will be my answers to that. But remember what I have to do. I have to put these into the original equation to see if they truly work. So let's see here. The square root of 10 minus 1 equals 10 minus 7. That's the square root of 9 equals 3. And so that is true. The 10 works. Let's try the 5. All right, the square root of 5 minus 1 equals 5 minus 7. The square root of 4 equals negative 2. That actually doesn't work because the principal square root of 4 that we want to have here is 2. 2 equals negative 2 does not work. So the 5 is not a true solution. That's called an extraneous solution. Extraneous solution. So the 10 is the only true solution there. Okay. All right, third example of solving radical equations. This one's going to be much tougher. It's going to hurt a little bit. If I have two different radicals in this equation, kind of the steps to do this are, first, you want to isolate one of the radicals. And usually the one you want to pick is the one that's a little more complicated than the other one. So I'm going to get this radical by itself. I'm going to move this one over to the other side. That gives me the square root of 2x plus 3 equals 2 plus the square root of x plus 2. And from here, I'm going to get rid of this radical on the left by squaring both sides. That gets rid of this radical on the left, so I get 2x plus 3 equals. But on the right side, I have to FOIL this with itself, which is pretty complicated. All right, let's go through those steps. 2 times 2 is 4. Plus 2 times the square root of x plus 2 is 2 square root x plus 2. Square root of x plus 2 times 2 is, again, 2 square root of x plus 2. And the square root of x plus 2 times the square root of x plus 2 is a square root of x plus 2. Oh no, what did you do? Let me undo that. It made a shape that I did not want it to make. Is the square root of x plus 2 squared. All right, so that gives me 4 plus 2 of these things plus 2 more of these things is 4 of those things. So that's plus 4 square root of x plus 2. And then the square root of x plus 2 squared is x plus 2 because the square root and the squared cancel. So you just get plus x plus 2. Now, if I simplify that by combining like terms as much as possible, I get x plus 4 square root x plus 2 plus 6. All right, where did that 6 come from? It came from the 4 and the 2 adding together. Okay, now what I will do is I will subtract the x and subtract the 6 to combine them with their like terms over on the left. Minus x minus 6. That gives me x minus 3 equals 4 square root of x plus 2. Okay, so now I've gotten rid of one of the radicals. I only have one more, so I got to get rid of that one too though. So I'm going to go ahead and get rid of it now. I'm going to get rid of this radical by squaring this side, and I have to square this side too. So what that's going to give me, over on the left side, it's going to give me x squared minus 6x plus 9 after you FOIL that left side out. On the right side, I've got to square the 4, that's 16, and I've got to square the square root of x plus 2, which is just x plus 2, because the square root and the squared cancel out. Now I'm going to distribute the 16, so I've got x squared minus 6x plus 9 equals 16x plus 32. Now move the 16x and the 32 over here with their like terms. That should have been minus. That gives me x squared minus 22x. Oh, that's too many threes. Minus 23 equals 0. And again, from here you have choices, but I would prefer to factor it if it will, and this will factor. That's x minus 23 and x plus 1. So I get x equals positive 23 and I get x equals negative 1 if I set those equal to 0 and get x by itself. But now remember what we have to do. We have to check them. Check both of those. So 23 and negative 1 in this original equation. The square root of 2 times 23 plus 3 minus the square root of 23 plus 2 equals 2. All right, 23 was the answer, wasn't it? 23 and negative 1, yeah. So let's see how this works out. That's going to be the square root of 46 plus 3 minus the square root of 25 equals 2. That's the square root of 49 minus the square root of 25. That's 7 minus 5, and that is correct. So the 23 is a good answer. But now we got to try negative 1. All right, let me try negative 1. The square root of 2 times negative 1 plus 3 minus the square root of negative 1 plus 2 equals 2. So that's going to be the square root of negative 2 plus 3 minus the square root of 1 equals 2. So that's the square root of 1 minus the square root of 1 equals 2. Well, that's 1 minus 1 equals 2. 0 equals 2 is not right. So my answers are, the negative 1 is not a true answer, so 23 is my only answer. All right, the next kind of equations are equations that are quadratic in form. All right, let's talk about what that means. So quadratic in form means that we could, if we can figure out a way to kind of manipulate this equation to make it appear as a quadratic equation that we can solve with our normal quadratic methods. That's what that means. And we're going to do that. It's pretty clever, but you don't have to do it to solve these things. It's just a clever and quicker way to do things sometimes. And it's pretty neat. But if you didn't know how to do it, you could still solve this example right here. This x plus 2 squared plus 11 times x plus 2 and so on and so forth. You could solve that by hand by foiling out the x plus 2 squared, distributing the 11, combining like terms, and then going from there. Or even by doing it in the calculator as I've showed you before. But the clever way to do it by hand would be to make a dummy variable called u. U is called the dummy variable. This is even called, you could call this u substitution. We're going to let u equal, so dummy variable, look for something in here that's the same. The x plus 2 is the same in both terms, so I'm going to let u equal x plus 2. And so since u equals x plus 2, anywhere there's an x plus 2 in this original equation, I can replace it with a u. So that this now becomes u squared plus 11u minus 12 equals 0. Then this is why it's quadratic in form, because now it's a quadratic equation that we can just use a pretty simple way of factoring it to solve it. It's going to be u plus 12, u minus 1. So solve those and you get u equals negative 12 and you get u equals positive 1. But we're not trying to solve for u. And here's where you're going to undo that little trick that you did before, because u is what? U is x plus 2. So x plus 2 is now going to go back in. So now x plus 2 equals negative 12 and x plus 2 equals 1. Now solve both of these. And you get x equals negative 14 and x equals negative 1. Looks like negative 14 and negative 1 are the answers. Okay. Look at this second example of quadratic in form. Look at this and see, can I make u be something to where this equation would become u squared with something with a u and then a constant. What can I let u be to replace in this equation so that this first term might become u squared and the second term might become something with a u and so on? I'm going to let u be the square root of x. Because if I let u be the square root of x, then if I square both sides, I get u squared equals x. So that makes this equation become, I can substitute u squared in for the x. I can substitute u in for the square root of x, and it becomes u squared plus 2u minus 3. And I can solve it by some simple factoring. U and u, that's going to be plus 3 and minus 1. So u is going to equal negative 3 and positive 1. All right. You didn't have to solve it this way. You know, you could have isolated that square root of x and squared both sides. But again, this is just kind of a little bit more clever way to do it that makes it a little bit easier. We haven't finished yet, by the way. We have to now substitute back in for u. What was u? U was the square root of x. That has to go back in. So the square root of x equals negative 3, and the square root of x equals 1. Square both sides here. We get x equals 9. Square both sides here. We get x equals 1. So 9 and 1 appear to be the answers. But since there are radicals involved here, I do need to check this one. I need to plug them back into the original equation. Notice I didn't have to do that in the previous example because there were no radicals involved there. So I didn't even have to do it. But let's plug it back in to see if it works. What do we get? We get 9 and 1. So let's see. 9 plus 2 times 9, the square root of 9 minus 3 equals 0. 9 plus 2 times 3 equals 0. 9 plus 6 minus 3 equals 0. 9, that's going to be 15 minus 3 equals 0. That's definitely not going to work. 12 does not equal 0. So 9 is not truly a good solution. Now let's try 1. 1 plus 2 times the square root of 1 minus 3 equals 0. 1 plus 2 times 1 minus 3 equals 0. 1 plus 2 minus 3 equals 0. 3 minus 3 equals 0. 0 equals 0. That works. So 1 is truly a good solution. And it's the only good solution here. All right, that was quadratic in form. All right, next I'm going to do equations that are higher order kinds of factoring. So not just factoring quadratics, but factoring higher order types of equations. So this one is x to the 4th minus 4x squared. What I want to do is move the 4x squared over here with the x to the 4th. So x to the 4th minus 4x squared equals 0, because factoring only works when you have 0 on one side of the equation. Now, what kind of factoring can I do here? Well, I can factor out a GCF. What is the GCF? It is x squared. And that leaves me with x squared minus 4. From here, I can actually factor this part some more. That's a difference of squares, so I can make that be x squared, and this factors down into x plus 2, x minus 2. So now I set all three of these equal to 0, so I have x squared equals 0, I have x plus 2 equals 0, and I have x minus 2 equals 0. So that gives, take the square root of both sides here. So the square root of 0 is still 0, so I get 0, move the 2 over, I get negative 2, move that negative 2 over, I get positive 2. So 0, negative 2, and positive 2 are my answers here. I don't have to check it because there were no radicals involved. Those are the answers. I should get 4 answers, and I actually do, because the 0 is actually a double root, because that x squared means that that's an x and an x. So I get x equals 0 actually twice. So that's called a double root. We'll talk more about that later. All right, next example. Okay, if I'm solving this equation, if I'm solving a polynomial that has more than 3 terms, I'm going to do a different kind of factoring. It's called factor by grouping. Factor by grouping. Okay, and what I do is I split those 4 terms up into 2 groups of 2. In the first group, I will factor out the GCF, which is x squared, and that leaves me with x minus 1. And in the second group, I'll factor out the GCF, which is going to be 4. But anytime the first term is negative, you're going to factor out the GCF as a negative. So I'm going to factor out a negative 4. And so I'm dividing both of these by negative 4. That leaves me with positive x minus 1. So now look what happens. For factor by grouping to work, these two things in the parentheses need to be the same, and they are. So this is going to work. What I do is, the x minus 1, since they are the same, they are the new GCF. Okay? Think of this as a big term, and this is a big term. What do they have in common? X minus 1. So I'm going to factor out that new common GCF of x minus 1. And if I factor x minus 1 out of this one, it leaves me with x squared. And if I factor x minus 1 out of this one, it leaves me with minus 4. And that's how factor by grouping works. Now notice here, I can factor that one some more because it is a difference of squares. So it's going to factor as x plus 2, x minus 2. So now I get x equals, if I do all three of those equal to 0, I'm going to get 1, negative 2, and positive 2. If you want to put plus or minus 2, 1 and plus or minus 2, that's okay. All right, that is how you do factor by grouping. And our last kind of equation to solve here in 1.5 is solving an absolute value equation. Okay, to solve this absolute value equation, I'm trying to get x by itself. And the way that I get x by itself is by doing the opposite of what I'm trying to get rid of. So to get rid of the plus 2, I can go ahead and just do minus 2 on both sides. Leaves me with the absolute value of 2x minus 3 equals 5. But now, how do I get rid of an absolute value? Like, what's the opposite of that? I can't really do it that way. But the way that I can get rid of an absolute value is to realize what absolute value means. Absolute value means the distance from 0. Distance from 0. Okay, that's what absolute value means. So whatever is in here, in this case the 2x minus 3, it means that the distance of 2x minus 3 from 0 is 5. Or let me say it another way. 2x minus 3 is 5 away from 0. Well, let's look at a number line. Here's 0. What is 5 away from 0? 5 is 5 away from 0, but something else is also what? Negative 5 is also 5 away from 0. So 2x minus 3 it could be at negative 5 or it could be at positive 5. So we solve them both. We say 2x minus 3 equals negative 5, and we say 2x minus 3 equals positive 5. And we solve them both. All right. I'm going to do it kind of fast. 2, so x equals negative 1 when I divide by 2. All right. Add the 3 here. 2x equals 8 divided by 2. X equals 4. So negative 1 and 4 are my answers here. All right, and that makes sense because I don't know if you remember, but absolute value looks like this. So it could definitely cross a particular height or particular value at 2 places. All right, that's the answers. I want to show you that you could also solve this in your calculator if you know how to type it in. We're going to put the left side into y1, and we're going to put the right side into y2. Let me pull up my calculator. And I'll show you how to type it in. Come on, calculator. Please, come on. You're holding up progress. All right. So I am going to type in the left side into y1. Clear that out. How do you type in an absolute value? I'm glad you asked. You click the math button. Here's the math button right here. And you click over to num for number, And the first option says ABS. Well, that stands for absolute value. And so that puts you some absolute value bars there. And I type 2x minus 3. Then I make sure I go click to the right to get outside of the absolute value, and I say plus 2. And then for y2, I can type in the left side, which is just that 7. I'm going to put 7 for y2. I'm going to click graph. And notice here is this blue thing is my absolute value expression, and this red thing is my my constant expression. And I'm trying to find where they cross. Finding where they cross will give me the answer. So the second calc, option 5 is intersect. First curve doesn't really matter. It can be the blue one. The second curve can be the red one. And when it says guess, I'm going to take it near where it crosses it to the left. And it is -1 for x, which is what we already found. Let me do it again to find the one on the right. Intersect. First curve, enter. Second curve, enter. I'm just going to, when it says guess this time, I'm going to click to the right until I get, stop. Until it gets closer to this one over here. And then I'm going to click enter. And it gives me 4 as the other answer, which is what we got over here. That's how you can do it in your calculator. All right. Good luck on the assignment for 1.5. I'll see you again in 1.6 or 1.7.